Chapter 11 Technologies of the Future. Did you know Apple's Siri, Microsoft's Cortana, IBM's Watson, Amazon, Netflix, Google, Facebook and LinkedIn all have been using these intelligent algorithms to analyze our online movements, interests and networking with others. When we browse through social websites and online stores, a lot of suggestions pop up or slide in our way. Where have they come from? A programmed component of the website or mobile app is doing it. The big question is, how do these programs know what we might be interested in? Answer is, we are tracked right from the moment we log on to any online platform until we log off. Our browsing pattern is called browsing signature or browsing habit. The tracking programs compile browsing signatures of millions of visitors daily. Analysis of this huge mass of data produces useful patterns of a visitor's browsing habits, interests, and buying preferences. This is an example of the use of AI, artificial intelligence. Artificial intelligence is poised to have a major impact on nearly every area of our lives. However, AI is not the only technology that is changing our lives. There are several other technologies which are changing the world around us. We will learn about some of these futuristic technologies in this chapter. Chapter 11 Artificial Intelligence. The term artificial intelligence was first coined by Stanford researcher John McCarthy in 1956. Artificial intelligence is the ability of a machine to think and learn. Machines containing AI should be able to interact with their environment and perceive it through various stimuli such as visual perception, speech recognition and language understanding in the form of received data and respond to them, depending on accumulated intelligence. As a consequence, because of AI, the core notion of the operation of computers of input, processing, output can be reformulated as data, analysis, prediction. Artificial intelligence versus human intelligence. Human intelligence works naturally and takes decisions by using reasoning. On the other hand, artificial intelligence works on a model that behaves like humans. Artificial intelligence is an artificial thing and human intelligence is a natural thing. Human intelligence works in the form of signals and artificial intelligence is digital. Artificial intelligence is based on hardware and software, but human intelligence is not based on these issues. Types of artificial intelligence. AI. There are three types of artificial intelligence. 1. Artificial Narrow Intelligence ANI. 2. Artificial General Intelligence AGI. 3. Artificial Super Intelligence ASI. Let us understand more about these. Artificial Narrow Intelligence ANI, also referred to as weak AI or narrow AI, is the only type of artificial intelligence we have successfully realized to date. Narrow AI is goal-oriented, designed to accomplish a single task such as facial recognition, speech recognition or voice assistance, driving a car or surfing the internet, and is extremely competent at fulfilling the objective. While these computers appear intelligent, they are constrained by a set of rules and limits, which is why weak AI is a term used to describe them. Narrow AI does not attempt to copy or replicate human intelligence. Rather, it replicates human behavior using a limited set of characteristics or circumstances. Narrow AI has experienced numerous breakthroughs in the last decade, powered by achievements in machine learning and deep learning. For example, AI systems today are used in medicine to diagnose cancer and other diseases with extreme accuracy through replication of human-like cognition and reasoning. Some successful examples of narrow AI: RankBrain by Google or Google Search, Siri by Apple, Alexa by Amazon, Cortana by Microsoft and other virtual assistants. IBM's Watson, image or facial recognition software, disease mapping and prediction tools. Artificial General Intelligence (AGI), also known as strong AI or deep AI, is the idea of a machine with general intelligence that can learn and apply its intelligence to solve any problem. In every given context, AGI can think, understand and act in a manner that is indistinguishable from that of a human. Strong AI is yet to be realized by AI researchers and scientists. They'd have to figure out a means to make machines conscious and program them with a full set of cognitive abilities in order to succeed. Machines would have to take experiential learning to the next level, having the ability to apply experiential knowledge to a wider range of situations rather than merely boosting efficiency on single activities. Artificial Superintelligence (ASI) is a hypothetical AI that would enable computers to become self-aware and exceed human intelligence and ability. For long, superintelligence has been the inspiration behind science fiction thrillers in which robots overrun, overthrow, and/or enslave humanity. Artificial superintelligence is the idea that AI will evolve to be so similar to human emotions and experiences that it will not only understand them but will also elicit emotions, wants, beliefs, and goals of its own. Three types of artificial intelligence. Artificial Narrow Intelligence (ANI). Stage 1. Machine Learning. Specializes in one area and solves one problem. Artificial General Intelligence (AGI). Stage 2. Machine Intelligence refers to a computer that is as smart as a human across the board. Artificial Superintelligence (ASI). Stage 3. Machine Consciousness. An intellect that is much smarter than the best human brains in practically every field. Siri, Alexa, Cortana. Types of artificial intelligence. Domains of AI. Artificial intelligence is a computer system that is able to perform tasks that ordinarily require human intelligence. Artificial intelligence systems are critical for companies that wish to extract value from data by automating and optimizing processes or producing actionable insights. Let us have a look at the following three domains of AI and discover how they are related to each other: data, computer vision, natural language processing (NLP). Let us understand these domains in detail. Data. Data is also required for processing of AI-driven machinery. Data can be structured for processing using AI systems. In fact, for an AI system, a large and steady inflow of data is required. The more data there is, the better an AI system may be used. The ability of AI system to manage large amounts of data is a distinguishable attribute. The reason for this is that an AI system does not process data in the same way that a regular computer does, depending on what it has been instructed or trained to do. An AI system analyzes the data and tries to detect some form of trend or pattern in it. For example, if an AI system used by an e-commerce website is expected to forecast how many people are going to buy a popular product in a future year, then more the purchase data for that product that is accessible, the better. Because there will be more factors to analyze. If there are more purchases of that product, the predictions will be more accurate. As a result, the more data there is, the more accurate the prediction is. Computer vision. The AI domain of computer vision deals with the processing of pictures and video in order to recognize patterns. Intelligent machines sift through massive amounts of graphical data in search of one or more patterns. The concept of computer vision is based on teaching computers to process an image at a pixel level and understand it. Technically, machines attempt to retrieve visual information, handle it, and interpret results through special software algorithms. Computer vision algorithms that we use today are based on pattern recognition. We train computers on a massive amount of visual data. Computers process images, label objects on them, and find patterns in those objects. For example, if we send 1,000,000 images of flowers, the computer will analyze them, identify patterns that are similar to all flowers, and at the end of this process will create a model flower. As a result, the computer will be able to accurately detect whether a particular image is a flower every time we send them pictures. Natural Language Processing, NLP. It is a branch of artificial intelligence that helps computers understand, interpret, and manipulate human language. NLP draws from many disciplines, including computer science and computational linguistics, in its pursuit to fill the gap between human communication and computer understanding. How are the three domains related to each other? Though we learned about the three areas of AI separately, they are virtually intertwined. In computer vision, data in the form of pictures is useful, and data in the form of speech, voice, audio, and music can aid natural language processing. When data is accessible in the form of audiovisuals, both computer vision and natural language processing (NLP) are used. Text, speaking, gestures, signs, signals, writing, and expressions are all ways we communicate. All of these methods assist us in perceiving the world around us. The above modes of communication can be divided into two categories: vision and language. Vision forms the basis of visual communication to or by a machine. It involves reconstruction of the perceived image in the brain of the machine. Here, the machine is trying to perceive the visual input. Then it is recognized, and finally, the image is reorganized in the brain of the machine and the perception is completed. For example, recognizing a face, understanding facial expressions to figure out the emotions, perceiving a 3D world as simple as a small empty box and as complex as a crossroad of a metro city during rush hour. So, very efficient and useful applications can be designed by integrating data, computer vision, and NLP. Examples of artificial intelligence. Some prominent examples of the use of AI in today's world are as given below. 1. Smart assistants. Built-in smart assistants on our phones like Siri, Alexa, and Google Assistant are the more obvious examples of AI that most of us are aware of and use. 2. Navigation apps on phones. Believe it or not, even your daily commute to and from work requires the use of artificial intelligence. Navigation apps such as Google Maps use AI to analyze the speed of movement of traffic. It also takes in user-reported incidents such as traffic accidents or road construction to predict how long it would take you to reach your destination and uses that information to suggest the fastest route. 3. Rideshare apps. Now, suppose instead of driving yourself to work, you choose to take an Uber to your office. How do rideshare apps determine the price of your ride or the wait time once you call an Uber? The answer is machine learning, another example of artificial intelligence. According to Uber's head of machine learning, Danny Lange, a rider's wait time is based on data from millions of trips, which lets Uber take into consideration normal patterns that occur day after day. 4. Facial recognition. Apps are using AI in their facial recognition technology. Snapchat uses AI to recognize users' faces and apply face filters to users' photos. In Facebook, facial recognition is used to identify faces in photos and invite users to tag themselves or their Facebook friends. 5. Spam filters. You may be hesitant to believe that your email inbox employs AI, but it's true. One of the most important features of your inbox, the spam filter, is regulated by a set of rules that help keep your inbox risk-free. Over time, spam filters continuously learn from various signals ranging from an email's metadata to specific words or phrases in an email. Gmail itself is able to successfully filter out 99.9% of spam through the use of its machine learning algorithm. Domains of AI. Artificial Intelligence. Internet of Things, IoT. The Internet of Things, IoT, is the concept of connecting any device with an on or off switch to the Internet and to other connected devices. It is a giant network of connected people and things, all of which collect and share data about the way they are used and about the environment around them. This includes an extraordinary number of objects, including smartphones, smart home appliances such as smart fridge, self-driving cars, wearable fitness devices, and more. Note, in 1999, Kevin Ashton, then at P&G, later MIT's Auto ID Center, coined the term Internet of Things. Benefits of the IoT. This interconnectedness has brought about immense benefits to consumers in terms of productivity, convenience, time and cost savings, and a better quality of life. These benefits are a result of three key factors enabled by IoT. Remote monitoring. Users can access data and information easily, remotely, and in real time, reducing the need to make physical trips. Automation and control. With machine-to-machine, M2M communication, devices can stay connected and manage everyday tasks without the need for human intervention. Predictive analysis. With IoT, users can know things in advance. Example, in healthcare, smart sensors analyze health conditions and lifestyle choice and recommend preventative measures to reduce disease occurrences. How does the Internet of Things work? The IoT doesn't rely on human intervention to function. With the IoT, sensors collect, communicate, analyze, and act on information, offering new ways for technology, media, and telecommunications businesses to create value. As a result, data is being shared through the IoT among many more participants, and as a result, more sensitive data is being shared. Thus, the risks are exponentially greater. Security challenges in the IoT. According to a forecast by Business Insider, there will be over 64 billion IoT devices by 2025. Despite these trends, there are still a few key IoT security challenges to be addressed in order for us to fully harness the potential of IoT. Outdated hardware and software. A majority of IoT devices either do not get the appropriate updates or never get a single one. This means the products become vulnerable to attacks when hackers find bugs or security issues. Use of weak and default credentials. Many IoT companies sell devices and provide default credentials with them which are easy to find and often used by hackers to carry out brute force attacks to compromise these devices and use them for nefarious purposes. Malware and ransomware. The rapid rise of IoT products makes cyber attack permutations unpredictable. Cyber criminals have been able to lock consumers out of their own IoT devices. Data security and privacy. With increased interconnectedness, data protection has become more difficult as it gets transferred between multiple devices within a few seconds, which can lead to a data leak. Everyday uses of IoT. While technology transforms our lives, the Internet of Things, IoT, is generating a lot of hype. Even if we don't always see it or realize that a device is part of the IoT, the Internet of Things is all around us. The Internet of Things, IoT, is transforming physical items into a data-sharing ecosystem between wearable, portable, and even implanted gadgets, allowing us to live a more technologically and data-rich life. IoT is bringing connected intelligence to our homes, offices, and vehicles. Smart speakers like the Amazon Echo and Google Home make it quick and convenient to play music, set timers, or get information using voice commands or mobile app controls. Internet of Things. Blockchain. Blockchain technology is a software, a protocol for the secure transfer of unique instances of value. Example, money, property, contracts, and identity credentials via the internet without requiring a third-party intermediary such as a bank or government. It can be described as a digital, decentralized, distributed ledger that keeps a record of all transactions that take place across a peer-to-peer network. It is an interlinked and continuously expanding list of records stored securely across a number of interconnected systems. Let us understand this definition in detail here. A ledger is like a database, a Google or Excel spreadsheet. It is possible to add new records by appending rows. Each row contains information about account balances and owns certain assets. The key innovation in blockchain technology is that it allows its participant to transfer assets across the internet without the need for a centralized third party. Blockchain technology was developed as the underlying technology behind the cryptocurrency called Bitcoin. Blockchain. Bitcoin. Bitcoin is digital money that allows for secure and seamless peer-to-peer transactions on the internet. It was created by Satoshi Nakamoto, a pseudonymous person or team who outlined the technology in a 2008 white paper. It's an appealingly simple concept. Bitcoin is decentralized. Any two people anywhere in the world can send Bitcoin to each other without the involvement of a bank, government, or another institution. Every transaction involving Bitcoin is tracked on the blockchain, which is similar to a bank's ledger or log of customers' funds going in and out of the bank. In simple terms, it's a record of every transaction ever made using Bitcoin. Unlike a bank's ledger, The Bitcoin blockchain is distributed across the entire network. No company, country, or third party is in control of it. Anyone can become part of that network. There will ever be only 21 million bitcoins. This is digital money that cannot be inflated or manipulated in any way. The currency began to be used in 2009 when its implementation was released as open source software. It isn't necessary to buy an entire Bitcoin. You can buy just a fraction of one if that's all you want or need. Bitcoin. Sum up. Bitcoin, B, is a decentralized digital currency without a central bank or single administrator that can be sent from user to user on the peer-to-peer Bitcoin network without the need for intermediaries. Blockchain technology is a system of recording information which is secure and hack-proof. This technology is being used in cryptocurrencies like Bitcoins. Artificial intelligence, AI, is a futuristic technology that is poised to have a profound impact on our life in the years to come. Artificial intelligence refers to the process of imparting human-like intelligence and abilities to the machines. AI is of three main types: artificial narrow intelligence, artificial general intelligence, and artificial superintelligence. Data, computer vision, and natural technology processing are the three main domains of AI. The Internet of Things, IoT, refers to the network of physical objects or things that are embedded with sensors or software, etc., for the purpose of connecting and exchanging data over the Internet.